Alrighty, working on a 2008 Buick Enclave with the 3.6 V6. Issue is, it was overheating excessively. It would go in the limp mode, reduced power mode. So the individual took it to a local dealer, the same local dealer that I always talk about in my videos in Mountain Home, Idaho, that, well, they can't diagnose nothing, right? They throw parts at everything and they can't diagnose anything correctly. So if you look here, what they put down, it was overheating. They said it needed new head gasket set, resurface heads, heater hose, spark plugs, water pump, coolant, oil filter, intake gasket, exhaust gasket, right? It may need some of this, but we're going to do some tests to see what's going on. So they quoted everything with diagnostics, $34.53, almost $3,500. So initial look at it, the upper hose down here going to the radiator, and the lower hose where ice cold one is running, and the antifreeze was topped off. So the guy that owns the vehicle put a new water pump in it, a new thermostat. I wasn't moving any water, burped it, got all the air bubbles out, and now everything's cooling correctly. So now we're going to do some checks to make sure the heads ain't warped, the head gaskets ain't leaking, you know, no low compression. So what I did is I hooked up the autel with my oscilloscope. I did a clear flood, clear flood crank. So you smash the gas pedal all the way to the floor, crank it over, it disables the fuel injectors, and you can crank it over and check for relative compression. I have my high amp clamp on the cable going to from the battery to the starter. If you look here, I zoomed in, all these humps are even, right? Pretty even. So if I had one that was low, which I'll show in the next part of this video, because we're going to take a plug out and just to show that. If it was low, I'd have, you know, a weak compression, head gasket, you know, all these are the same, right? So if the head gasket was leaking on one of the banks, you know, one of these or two of these or a few of these would be a lot lower than the other one you would expect. Because this one's kind of hard to do a compression check on. The first 3 cylinders are easy, but the back 3, well, they're not as easy to get at. So right now we don't even need to get at the back 3, but again, if we had a low one, we would go after that. So now we're going to remove the spark plug and do the next test. Alrighty, so now we're going to do the same test, but just to show you guys, I got one of the center spark plugs out. I just want to show you the difference on the scope. Go ahead and crank it all the way to the floor and then crank it over till I tell you to stop. Stop. You can turn it off. So if you guys heard there, you can hear that audible tone difference. So there's a dead cylinder. So now what I'm going to do is stop on my scope here, rewind, back up a screen, zoom in. Well, if you look, there's the dead cylinder, there's the dead cylinder, there's the dead cylinder. It's not dead, it's because we took the spark plug out. Well, say that was the back cylinder that was dead in this case. How would you know what cylinder that is? You'd put a second channel on, like, say this ignition coil here. And then you would, you know, basically write in the firing order, whatever it is. If it's 1, 3, 2, 5, I don't know what the firing order is, I'd have to look it up. But you would write that in, and you would know that cylinder, whatever it is, right? But we don't need that for this test. So now what we're going to do is put an actual mechanical compression checker in there, tester in there, to ensure, see what numbers we're getting from our previous data, and then we know all the cylinders are about the same. Alrighty, so we did a mechanical compression check here. We're almost at 150, 145, 150 PSI. The battery's a little weak on this, so probably been just a little bit more if we had a good battery on this, but we're going to eventually get to that, replace the battery. So 145, 150, well, if you remember looking at the scope, all those readings were about the same, so we got around 145, 150 on all 6 cylinders. So mechanically, I mean, our valves, our rings, and our head gasket, we're assuming is all good, but we're going to go ahead and do some other checks just to prove that theory and go from there. Oh, and also, since, you know, we're reading 145, 150, the minimum per the service data is 140 PSI minimum, which we're obviously within. Like I said, I think we'd have a little bit more if we had a better battery, because the battery is very weak, but we are within the specs. Alrighty, so now we're going to do the block test. I don't believe there's no need to do this since everything else passed, but we'll ensure that the head gasket is not leaking, or both head gaskets are not leaking, no heads are cracked, and so forth. So you fill up this tester here to the line with the blue chemical that comes with. Then you make sure that your radiator have at least, I don't know, 4 or 5 inches below the surface, because it is going to fill up when it runs or expand. Take the cone, put it in there so it's sealed. Got your check valve here. And we're going to run it. We're going to pump it like this. You can see it draws air in from the radiator. It goes through that little strainer there. And it starts blue. And if the head gasket or head's cracked, this chemical will turn light green to a yellow, and basically telling you that there's combustion gases going into the antifreeze, into the radiator. So what we're going to do now is go ahead and start it. And you want to, he's going to go ahead and pump it. He's going to keep pumping it. He's supposed to pump it for a while. Directions say 2 minutes for pumping it. We've already done it for a few minutes and we had no changes. So we're going to continue to make sure. And like I said, that ensures that there's no combustion gases from the head gaskets, cracked heads if there was one, which I don't believe there is, going into this. Because if you remember, on the thing from the local dealer mountain home, they said it failed the block test. Well, that's why they want to replace all this. Well, every test we've done so far, it's passed. Can you go ahead and rev it a little bit while he does this? Rev it a little bit more. A little more. Or stop. So we're just doing different tests here. We've been doing this for a couple minutes now. We'll do a little bit longer. But if you look, the fluid is still blue. So, yeah, everything's passing. Like I said, we captured this on, we didn't capture this on video earlier, but we've done it for a few minutes earlier. It's not turning light green or blue, light green or yellow, which we wouldn't expect it to, because the relative compression check, the misfire analysis, all that stuff passed. It doesn't have a long crank time. It doesn't have any smoke coming out the tailpipe. So yet again, the local dealership in Mountain Home, Idaho, troubleshot, misdiagnosed this vehicle, and they're going to charge this customer $3,500 simply because, well, they don't know what they're doing. So now we're going to go into the vehicle and do a couple other tests for misfires, make sure there's no misfires. And that already, so it passed that test. Like I said, the local dealer in Mountain Home, Idaho is wrong, but I do want to show you guys how this color will change. So we're going to hook it up to the exhaust back here because it is running, and obviously that's burnt emissions, right? So it should change. If he pumps it in there, he's going to pump it a few times. Look at it right away. Yellow, light green to yellow. See that? Obviously that proved that this test does work. We're going to have results back here because it is getting the combustion gases in there, but on the front of the vehicle, everything passed. Now we're going to move on and do the misfire analysis, make sure all that stuff's good, and we'll be done. So now we're running. The temperature's right in the middle at 210 degrees. We're going to look at, make sure there's no misfires going on, which I don't expect none, per cylinder. Sorry about the glare. So if you look here, misfire current for each individual cylinder, none, and for the history, there's none either, right? That's your cycles of data. It's checking for misfires, but there's no actual misfires. Because if this thing had a head gasket leaking, it would have current misfires or history misfires, and there's nothing. That's just cycles of data going through. No misfires, every cylinder is running good to go. Now we're going to look at coolant temp, and I'll show you guys that next on the graph. So again, watching the coolant temp now, right under 210. On the outside, we're reading 206.6 degrees. We've been running around, I don't know, 5-10 minutes now. We're just going to keep running it to make sure the thermostat is opening and closing, and that both of these lines are warm, because before they were not warm because there was, with the water pump thermostat and air pocket issues going on. That one's hot and that one's hot. So the lines I'm looking at are down there, that hose, and that hose down there. They're all good to go. So the thermostat's opening and closing, cycling out correctly. So we're still at 206.6. We're just going to let it run a little bit longer here to show you guys the rest of the data. So now we're at to 210.2 degrees, 210.2. So we're about operating temp. Eventually the fans will come on and everything will be good. So fans are off right now, but they'll eventually both come on, cool this thing back down. But we are still within our, well within our operating temp. We'll continue to watch it a little bit more to make sure. Alrighty, so now we're at 215.6 on the data, but if you look, we're on the actual analog gauge around 210. Come out here, the fans are turning on right now, so that's good. We're going to make sure the temperature goes back down for the heat cycle. Thermostat opens, and this vehicle will be done, good to go. So we'll watch that real quick. And if you look, it's already dropping down. We're down to 213.8. We're at 215 and some change earlier. Now it's down to 212. We're dropping temp. Fans working. Thermostat's opening. Heat cycles are working. And that's where it wants to run, around 210 degrees for its operating temperature. We're at 210.2, so we're good to go. So, to recap on this, the local dealership in Mountain Home, Idaho, the one I always talk about, continues to misdiagnose. This car was overheating, got an evaluation on it, paid 120 bucks. They said it needed heads, machine, gaskets, water pump, thermostat, all this stuff. They wanted 3,500 bucks almost. Well, that wasn't the problem. The problem was it wasn't moving any water. Water pump, thermostat, it had air in the system. Replaced those, the water pump and the thermostat, got all the air out, did all the tests we just proved on video, everything's good to go. He didn't need to spend the 3,500 bucks. No damage was done to the heads, the head gaskets are nothing. So yet again, the local dealer in Mountain Home, Idaho is continually misdiagnosing vehicles' drivability issues for these vehicles. So if you look at the scan tool one last time, we're at down to 206. If it zooms in there or clears up, 206.6, right under 210, because the fan's cooling it back down. So the heat cycles are working as advertised. That is it for this video.